Assalamualaikum and hi. My name is Nur Anisafia binti Shamsul Kamal. My matrix number is 01DT23F105 and I'm going to explain the answer in question 1. So this is the coding. As you can see, my question is to construct a program to reverse the word in the program. So in line 6, we are using namespace std because it just makes your code easier to write. Um, the code using namespace std tells your compiler that if you find a method being called that is in std class, then immediately use method in that class. In line 9 and 10, there are comments to declare a stack to store words. The stack are using data type string. And in the line 12, there are comments to take input from the user. The data type is string to get the input, and in line 15, we are using getLine in input because getLine is a built-in function defined in a string that allows accepting and reading single and multiple line strings from the input stream. The getLine functions extracts characters from the input stream and appends it to the string object until the delimiting character is encountered. In line 17, we are using stream because it allows performing insertion and extraction. It is commonly used in parsing inputs and converting strings to numbers. In line 24, pop each word from the stack and print it reverse order. In order to get the reverse word, we have to use while condition. In line 32, we are using return 0 to get as a return statement. So here is the output. As you can see, when we enter words separated by spaces, ILE, the reverse word is ALI. And that's all from me.
Assalamualaikum and hi everyone. My name is Ibina Batisha binti Muhammad Amir. My matrix number 01DDP23F1121. So today I will explain about question number 2. So let's get through the coding. So first, we include IOStream for input and output operation, and I also use the state container to store each customer's order. And I also use queue to manage the sequence of customer. For the order structure, this structure represents an individual order with two fields. For the item, the name of the food, and the quantity is the number of the item ordered. For the customer order structure, the structure represents a customer order. It contains a stack of order object. Each customer orders are stored in a stack, meaning the last order added will be the first one prepared, that is LIFO. So for the main function is where the program execution starts. And for the initialize the queue and customer order, a queue to hold all customer order object, where each object represent a customer. For customer 1 and customer 2 are two customer order objects representing two different customers. So order for each customer are added to their respective order stack using push. Customer 1 has ordered nasi lemak for 2 quantity and nasi goreng for 1 quantity. Meanwhile, customer 2 has ordered mee goreng for 1 quantity and Maggi for 2 quantity. For customer or to add customer to the queue, both customer 1 and customer 2 are added to the order queue. Customer 1 will be processed first, followed by customer 2, as the queue works on a FIFO basis. Okay. Okay. For the while loop, a while loop is used to process each customer in the queue until the queue is empty. So order queue dot front retrieve the first customer in the queue and order queue dot pop remove them from the queue after processing. So current customer represent the current customer being processed. For a nested while loop processes, each order for the current customer until the stack of order is empty. So the current customer order dot top retrieve the top order, which the last order that was added, and current customer dot order dot pop remove it from the stack after processing. The current order hold the current order being processed. So for the each order is print with a message indicating the quantity and item name, showing that the order is being prepared. And the program returns 0 indicating successful execution. Okay, now let's go through for the output. Okay. Okay, for the output, as we can see, uh, the output look like this. Preparing 1 nasi goreng, preparing 2 nasi lemak, preparing 2 Maggi, and preparing 1 mee goreng. For the explanation, customer 1 orders are processed first in reverse order LIFO because they are stored in a state. Therefore, nasi goreng is prepared before nasi lemak, and customer 2 orders are processed after customer 1, also in reverse order. So Maggi is prepared before mee goreng. And this demonstrates how the queue and step work together to process multiple customer and their order. And that's all from me. Thank you.
Assalamualaikum and good morning. My name is Warianuha binti Sharifuddin and my registration number is F1102. Now I'm going to explain and answer question 3. Write a C++ program to show implementation of binary search tree using linked list. Your program must include basic operation in binary search tree including creating BST, inserting item into BST, deleting item from BST, and display data in BST. So I will show my coding. This one is my coding for question 3. This C++ program implements a basic binary search tree with function for inserting nodes, deleting nodes, and performing an in-order traversal. First, we look for struct. This struct represents each node in the BST. Each node stores an integer value or data and has pointers to two children, left and right. For class BST, this class contains the root node of the tree and various member functions to manipulate the tree. Then we're going to insert node. The recursive function insert a node with a given value into the tree. It checks if the tree is empty and create a new model if so. Otherwise, it insert the value in the left or right subtree based on the value is less than or greater than the current node data. Then we're going to look for delete node. The recursive function delete a node with the given key from the tree. First, it locates the node to delete by comparing the key with each node data. When it found, it handles with three cases. First, no children. Deletes the node and return null. Second, one child. Replace the node with its non-null child. Third, two children. Find the smallest node in the right subtree using mean value node. Replace the data with the smallest value and delete the duplicate node. In this coding, we use in-order traversal. This function perform an in-order traversal of the tree, left, right, and prints each node data displaying the value in ascending order. When we create BST tree, we add nodes with value 50, 30, 20, 40, 70, 60, and 80. Display and in order traversal of initial tree. Then we write deletes the nodes with the value 20 and display the in order traversal of the modified tree. And this is my output. This code will output the in order traversal before and after deleting the node with the value 20. So this is before delete 20 and this is after delete 20. So that's all from my question. Thank you.
Fix number 01 DDT 23 F1020. Today I'm going to show you how to find the target number 52 in a list using two different methods, which is linear search and binary search. In linear search, we go through each item in the list one by one until we find the target. First, we check the first number, which is 8, it's not 52, so we move to the next number. Then we check 11, still not 52, so we keep going. And then we continue the process by checking 19, then 25, then 34, and then 47. None of these are 52. Finally, when we reach 52 at index C, we found our target. So with linear search, we had to check each number one at a time until we found 52 at index 6. Now, let's try binary search, which is a faster way to find number in a sorted list. First, we look at the middle of the list. The middle number here is at index 4, which is 34. Since 52 is greater than 34, we can ignore the left side and only focus on the right side of the list. Now, we look at the middle of this right side, which is 55 at index 7. 52 is less than 55, so we only focus on the left part of these sections, which is indexes 5 and 6. Now we check the middle of these smaller sections. The middle is 47 at index 5. Since 52 is greater than 47, we move to the next number, which is at index 6. At index 6, we find 52. That's our target. So, the conclusion is with binary search, we found 52 at index 6 by dividing the list in half each time. So, it took fewer steps than linear search. That's all from me. Thank you.